All right, let's look at number 1 on the Pink's page. So they ask us to sketch a graph of 2 times 3 to the x power. Remember when we see that our a value, since a times b to the x power, our a value is our y-intercept. Ignore that. Our y-intercept would be at 2 there. Now we're not, and our b value is 3, so it represents exponential growth. We're not moving this up or down at all, so we're going to have a horizontal asymptote here at y equals 0. And it's, like I said, it's exponential growth. So those are the key features I want to see on the graph, the y-intercept and where the asymptote would be. So now the domain, remember that's the set of x values. The domain would go from negative infinity to infinity. Our y values is our range. We don't have any values below 0, so it's going to start at 0 and it's going to go up to infinity. But we would not have a bracket at 0 because there's no actual values at 0. And the end behavior, so as x approaches negative infinity, that's referring to the left side of the graph. The left side of the graph is not going infinitely down. The left side of the graph is getting closer and closer to that asymptote, which is at 0. On the right side of the graph, though, that is going infinitely up. And the equation for the asymptote is simply y equals 0. It's important that you have y equals. Y equals is for a horizontal line. X equals is for a vertical line. All right, let's look at number 2. So this is very similar to the previous one, except for we are going to the left 1 unit and down 4 units. So let's start with the fact that we're going down 4 units. So that means that our horizontal asymptote, that was at y equals 0, moving down to where y is negative 4. Now, the previous example, I'm just going to go back up to that, had a y-intercept at 2. Now we're going to move that point to the left 1 unit and down 4. So we had a point here at 2 originally. So we're going to go to the left. We're going to move that to the left 1 and down 4. 1, 2, 3, 4. That puts us right here. And again, the b value is 3, so it represents exponential growth going through that value. And so that would be our sketch of our graph. So the domain for this hasn't changed. It's still from negative infinity to infinity. But since we moved it down, the range, the y values are impacted. So the lowest value would be at 4, but it's not including 4, and it's going infinitely up. And the end behavior is going to change. As x approaches negative infinity, that's referring to the left side of the graph. The left side of the graph now is approaching that horizontal asymptote, which is at negative 4. Oh, by the way, I just realized my range should have been negative 4, so you might have been screaming at the computer that, oh, it's supposed to be negative 4, Mr. Murphy. Well, that's fixed now. Anyhow, the right side of the graph. The right side of the graph is approaching positive infinity. And our equation for our asymptote, remember this is a horizontal line, so it's going to be, the equation is going to be in the form of y equals, and that horizontal asymptote is at y equals negative 4. So that would be the equation for your horizontal asymptote. All right, let's look at number 3, which is the back side of that pink review. It says a Jeep Wrangler loses about 5% of its value a year. Now let's just stop there for a second. It's losing 5%. Now our rate as a decimal is 0.05. So remember, if we're losing value, we would subtract that value from that decimal, 0.05 from 1. If it was gaining value, we would add it to 1. So our b value, again, in our equation, y equals a times b to the x power, our b value would be 0.95, not 0.05. So a new one costs $34,500, so that's our initial price. Write an exponential model showing the value of a Jeep Wrangler X years after it was purchased. So our equation would be y equals our initial value, 34,000, not 24,000, 34,500, times our b value, which we talked about that a second ago, is 0.95, and our x represents our time in years. So in part A, when it says how much will the Jeep Wrangler be cost in 15 years to the nearest penny, we put 15 in there for x, and just type that in your calculator. When you do that, you get $15,983. We're going to round this to the nearest penny, so it'll be 55 cents. So that's how much it would be worth in 15 years. Now let's talk about part B here. So for this one, we could do this one of two ways. It says, how long will it take for the Jeep Wrangler to be worth less than 1,000? Let's just figure out when it would be 1,000, and so then it would be After that, that would be less than 1,000. So again, we're still dealing with the same Jeep. That was $34,500 when it was purchased. It's losing 5%, so our B value is 0.95 to the x power. So there's a couple ways we could solve this. If you want to solve this graphically, you could do that, where you would sketch this as two separate equations. We'd sketch that graph on your graphing calculator, sketch y equals 1,000 on your graphing calculator where they intersect at. That would be your solution. Let's say if you don't have a graphing calculator and you want to do this algebraically, or maybe you don't want to mess with changing your window settings and all the hassle that comes with it, you just want to get directly to the answer, we could do that. But I want to get my base by itself. So I'm going to divide both sides by 34,500. And when you do that, 1,000 divided by 34,500 is 0.02, I'll say 9. Oops, 9 got cut off there. There we go. All right, so now we're going to change, we can do one of two things. So we could take the log of both sides, or you could change the form it's in. I'm going to do more of that later, but I'll just show you how to do this if you take it right in log form. So our base would be 0.95, our value would be 0.029 equals your exponent, which is x. And some of your calculators will allow you to do this just typing it in as is, or we'd have to use a change of base theorem and type it in as log of 0.029 divided by the log of 0.95, and your final answer then would be about 69 years. So after 69 years is when the Jeep Wrangler would be worth less than $1,000. All right, let's look at this one. All right, so it says the number of Ebola cases in a town increases by 2.4% each day. So 2.4% as a decimal is 0.024, because you move the decimal to the left 2 places. Don't just put it in front, move it to the left 2, and it's increasing. So we're going to add that to 1. So our B value is what we're finding is 1.024. So there's 50 in town today, so that's our initial amount. We want to figure out how many there will be in X days from now. So this will be our equation. So we use that equation to answer the question. How many will there be in 29 days? We just put 29 in for X. And when you do that, you get approximately 99 cases. All right, so that's how you do the pink section. So hopefully that answers all the questions you might have had.